Hey there, everyone. The purpose of this lesson and homework assignment is to show you just how dramatically um, the cases of COVID-19 can increase because of exponential growth, which is the model for contagious diseases that contagious diseases follow, and why the U.S. is taking such uh, draconian measures or very strict measures right now to keep it from spreading. Okay, so as you may remember from the other day or last week, I think I showed you this website where you could download a lot of information that the World Health Organization keeps about cases of COVID-19 and deaths of COVID-19 by country. So I downloaded this data and put it into a spreadsheet, which I've posted with in Google Classroom with this assignment. And here's what the spreadsheet looks like. It shows you column A is the country, shows you the country, and each row represents, in column C, you'll have the number of days that have passed since January 21st. And then in column D, on that many days since January 21st, how many cases of COVID-19 that country had. So I'm going to show you Spain, and then for homework, I'm going to have you do the same thing, but for the US. So what I need to do is simply find the first entry for Spain. All right, and apparently it's February, it's like early February. Not all countries had cases before on January 21st. So for some of them, the first entry isn't until like, 5 or 11 or whatever past 1. So for Spain, I'm going to start and I'm going to highlight all the way down to day 56, which is January 17th or March 17th, so just yesterday. And I'm going to copy that, and then you're going to go to Desmos.com, click the Start Graphing button, and then make sure in the upper right-hand corner that you sign in so that your work will be saved. And then title your graph maybe like COVID-19 cases versus time. Okay, and then you're going to paste in the data that you had highlighted and copied out of that spreadsheet. I'm doing it for Spain. You'll do it for the United States. And then to fit the equation to the data, the exponential equation, you're going to type in row 2 y1, and then you're going to hit shift and do the tilde symbol. And then you're going to type A, B, and then shift to get and caret, so which is shift 6 above the 6 symbol, and then X1, and then you hit enter. And wow, that shows that an exponential curve pretty much models the data extremely accurately. All right, and the information that they give you for parameters are the values that you need to actually write the actual equation of that line. So in the case of what we just did, y equals AB to the x1. So what this tells you is the equation would actually have a value of A equal to 0.000698889 and a B value of 1.34. So what I'd like you to do for the United States is, and probably the easiest way to do this is on a piece of paper and not to type it out. You can type it if you want in maybe Google Docs or somewhere, but I'm just going to, but probably just handwriting it might be the best thing. So I'm going to type it for Spain. So it's going to be y equals 0.000698889 and then times 1.34139 and then raised to the x power. Okay, um, so that's my equation where x is the number of days since January 21st, and y is going to give is the number of cases that that equation would predict. Okay, so then the last thing that you're going to do, once you get that equation for the US, you're going to use a calculator and actually enter the data for with x being 100. So that would be 100 days after January 21st, which would probably be the very beginning of May. So like around May 1st, if the virus just continued to spread at the current rate, how many people in Spain would you expect to have the virus if there are that many people in Spain? So let's plug in our numbers and see what happens. So I'm going to do 0.000698889 times 1.34139 raised to the 100 power. And what do I get? I get, what is it? Let's see, 3,988,000, 3,980,000, no, 3,980,289,328 cases in Spain. Obviously, Spain does not have nearly 4 billion people. So at some point, the number of people is going to limit the virus's ability to spread. But still, that just shows you that how quickly something can get out of hand when there's exponential growth. And that's why one day we saw no news about Italy having a terrible crisis, and then it seemed like the next day, if you were watching the news, all of a sudden their healthcare system was overwhelmed and they were falling apart. People were dying like crazy. So that's why the U.S. is taking extreme measures right now to stop the spread of the virus. So to turn in your assignment then, what you should do is, if you hand wrote out your equation on a piece of paper, also hand write in the number that your equation predicts how many people in the U.S. would have COVID-19 at the end of 100 days. And then take a photo of that and email it to me. And then you should also share your graph with me. So you want to hit the share button and then copy the link and then email that link to me. All right, so send me two things: the equation and the number of cases after 100 days, and also a link to your Desmos graph. All right, I can't wait to see what the results are. I'm very curious. So on Friday, I think what we're going to do is on ordinary class days, on B days, I'm going to have a regular Google Meet at 2:15 to go over homework, answer any questions you have, maybe go over any assignment. It's not going to be a replacement for the lessons that I'm going to make in screencasts, but it'll be additional time to check in with me and ask questions and hopefully have your questions answered. All right, have a good night and be safe and healthy.